offer to designers. The next speaker I'd like to invite up is someone who comes actually from the industry, from the construction industry, where they use game technology on real-world problems to solve real-world design and implementation problems, and it has a direct benefit on the projects they do. So I'd like to invite the Senior Integrated Construction Coordinator for Mortenson, Taylor Cupp. Thank you, and I'm so sorry.
Understandable. I have a tough time saying it too. All right, enhanced visualization. Now more than ever, it has the potential to evolve the architectural, engineering, and construction process. With the rapid growth of video games and the video game industry, which is projected to breach the $100 billion mark for the first time in 2014, and the recent resurgence of mainstream virtual reality, it appears that the feasibility of integrating these technologies with other industries is very promising. Virtual reality has been talked about and experimented with commercially since the late 1960s. It has resurged and failed many times since then. However, the $2 billion acquisition of Oculus by Facebook probably tells us that it has a little more promise and is probably here to stay this time. The virtual reality market is untapped. It's projected to make up approximately $5 to $6 billion of the gaming industry in the coming years. It has a projected growth of 13,000% in the next 3 years, which is 5 times the growth rate of the iPhone between 2007 and 2010. This spark has led other industries to start experimenting again and take a serious look at potential uses outside of video games. The architectural, engineering, and construction industry is no different. These practices are becoming more and more integrated. In this talk, I'm going to take a look at how we are currently leveraging enhanced visualization techniques and their tangible value. We're going to look at why gaming and VR fit into this approach and why it's different than what it was just a few years ago. Architectural representation. So we've been designing and building structures for an eternity. And as long as there's been those built structures, there's been the need to communicate the ideas and concepts behind them. For just about as long, we've been representing these ideas in pretty much the same fashion. 725 BC, the Greeks were communicating design ideas with just their words and scale models. For the next 2,100 years, up to 1400 AD, and through the Renaissance era, some basic drawing conventions were developed. From 1400 AD to today, the basic representations that are still commonly used today were solidified, that being the floor plan, the building elevation, the building section, and the perspective. Through the majority of the computer era, we leveraged the computer to make the drawing and the representation of architectural design more efficient. However, we didn't really evolve the process itself. We just made it more precise and, as I said, more efficient. This is where we still struggle today. Not everyone that is embedded in these forms of drawing on a daily basis understands them. And oftentimes, those that don't understand it are the ones that it's totally crucial that they understand it, that being the users and the owners. The widespread use of 3D computer graphics in architectural and illustration in the past few decades has helped client understanding immensely. In most cases, a design idea is framed, materialized, and dramatically lit. Building information modeling has integrated this process with high-end visualization and streamlined it. However, the end product is typically a static image or a controlled animation, and that's just the issue, that they're controlled and static. The consumer is not free to explore. While the traditional form of architectural drawing serves a vital purpose in this process for designers and builders in the development of a design, I question if it really should be the most widely used way of explaining a design idea, a function, or an aesthetic. We're a society that demands engagement and interaction. We have relatively new tools that can allow us to tell a story in a much more compelling and interactive way than we have before. With building information modeling as a backbone of this whole process, many have already mastered the crucial first step in engaging AEC presentations and in gamifying architecture. This is not to suggest that we do away with the still rendering or the walkthrough animation. Rather, what if we start to look at a hybrid approach of embedding interactive content within the traditional forms of architectural representation in order to best tell a design story or explain a function? A question might be then, why is a general contractor interested in enhanced visualization as part of the virtual design and construction process? This year at Mortenson, we did a research project on our application of virtual design on a lot of different projects. Of our 10 primary VDC processes, the design review with our clients was found to be an integral part of our projects, leading to cost reductions and project efficiency. By ensuring that we get everything we can out of the design review, we increase our chances of ensuring that the owner is in full understanding of what they're about to spend their money on. Effective design reviews in the design stages of a project also make project teams much more efficient by decreasing the architect's chances of having to redraw, or even more costly, the general contractor's chances of having to tear out and rebuild. In the end, both of these benefits, cost reductions and productivity increases, provide a better experience for our owner than could have otherwise been realized. Our goal for design reviews is to enable enhanced decision making. We want the users of the projects to feel like the first time they walk in the building, that it's not really the first time, both aesthetically and functionally. We have found that the more real-time feedback we can provide and the more interactive the review can be, that the more effective the review is and more accelerated the whole process is. Not until relatively recently have we been able to easily facilitate a real-world perception of distance and scale digitally. There have been solutions for a while, but accessible, affordable, and portable solutions like the Oculus Rift has allowed us to achieve this need. Virtual design reviews have also contributed to reduced cost in physical mock-ups, as a fully detailed virtual mock-up is far less expensive to build than even a partial physical mock-up. It is also easily modifiable and has the potential to be interactive. In fact, interaction is key to this use and holds proof that more engaging, memorable, and valuable design review is achievable with more immersive experiences. The interactivity of these solutions is where the true benefit lies. As a builder, over the past decade, as we've kept a close eye on more innovative approaches to the conventional 2D and 3D design review, we have strived to ensure that various methods that we have looked at make sense. That's where a research project that we did recently with the University of Minnesota Architecture Department facilitated this whole thing into really starting to make sense. It questioned the applicability of not only gaming approaches to the design review, but also to more immersive approaches. Because we measure the performance of our processes and teams to drive value-add outcomes, we see it as crucial to ensure that there are beneficial ties to more enhanced visualization techniques. This past spring, a graduate student by the name of Will Adams looked at spatial cognition in virtual reality by developing an evaluation technique for our common representation methods in design review. Will set this up by creating a control method which analyzed a full-scale physical scenario where large cubes had a spatial arrangement on one side of a partition. That's what you see on the right-hand side of the image there. The subjects were allowed to assess the layout for a set period of time. They were tasked then with recreating that layout from memory on the opposite side of the partition. The same process took place under a second scenario, except that the subjects were left to assess and recreate the arrangements on a 2D screen. A third scenario took place where they went through the same process with a head-mounted Oculus Rift display in a seated position. And finally, in a fourth and final method, the subjects were made use of a more immersive virtual reality application where they were able to walk and explore the arrangement. They still had a head-mounted display, but they were able to physically navigate. So the findings of Will's research. He took measurements of each subject's arrangements and documented them based on how much overlap, or lack thereof, was created from the original layout to the layout that the subjects captured with their mind's eye. Okay, so the first situation. The control or physical, I guess physical to physical scenario, had the least amount of overlap in the arrangement. So the 2.31 feet, as Will mapped out everything that they had laid out, that was the amount of miss that they had in the physical to physical scenario. And the second solution, being the monitor, again, where we are most commonly reviewing our virtual mock-ups, there's 3.18 feet of overlap. Next scenario, the seated Oculus Rift situation, 2.83 feet of overlap. And then the final, the walking immersive condition, 2.57 feet of overlap. So the outcome of this study resulted in some solid proof of the concept that a more immersive design review, which was the walking VR solution in this situation, enhances spatial understanding and recollection, thus providing a basic foundation for our approach to leveraging alternate technologies to the traditional 2D design review. Okay, so some real-world applications for us. The following are benefits that we have seen from gaming applications in AEC visualization that we feel would not have otherwise been realized or much more difficult to accomplish without a gaming workflow. Each application is a different project type with different VDC objectives. So for Sanford Health, which is animating now in the bottom left, the Oculus Rift was leveraged to ensure that a full client understanding and buy-off existed. Detailed prototypes of various crucial areas of the hospital were generated. Spaces range from public spaces, such as the main hospital lobby, to critical care spaces, such as patient rooms, all the way to a detailed custodial mock-up, believe it or not. These prototypes were reviewed by not only the leaders of the organization, but also by the users. The mock-ups provided assurance that not only the look and feel was correct, but also ensured them, especially the caregivers, that the medical device placements were correct. Next example. At the Minnesota Vikings new stadium that's under construction right now, the team made use of Lumion early on in the project. Lumion's built on top of a gaming engine called Quest 3D. So it's not full-blown gaming, but it's still using gaming to leverage our workflow here. The power of Lumion was key because it more easily accomplished mass file consumption from a lot of different sources, provided real-time feedback to the users as they were reviewing it. So we were able to freely navigate, manipulate things, and modify them. Last but not least, a package deliverable was anticipated that we would provide to the owner following the design review, so that they could take it and in their systems and in their platform, review it at their own leisure. Next example, University of Minnesota 4th Street Resident Hall. During fully immersive virtual walkthroughs, issues were realized and remediated immediately rather than during construction. An example is something like the design position of a recessed can light in a shower stall. It was positioned too close to the wall, thus preventing the light from illuminating the stall adequately. Because IES data was applied to the light source, an accurate depiction of the light quality was able to be assessed. Well, it's a simple example. By having the model accurate and concise, the project was able to avert thousands of dollars in potential rework. Again, gaming applied to this because it was real time and we were able to manipulate it and see the results in real time. On all of these examples, while we didn't set out to use cutting-edge VR or gaming applications for that matter, at the onset of the project, the end goal was to leverage virtual design and construction in order to create better facilities for the customer by enabling them to make better decisions. The final example that we'll take a look at is at Penn State University. It served as an extremely important project for us in our enhanced virtual design review process, as it was one of the first projects where we realized the benefits of making use of some social virtual reality. So on the project, a more immersive design review was leveraged to drive downstream decisions earlier in the process, where they have minimal, if any, cost implications to the owner. The team made use of a cave to facilitate these decisions. create a shared vision, inform operations and maintenance to reduce post-cost construction changes, all of which led to the delivery of a world-class construction facility for Penn State's Division I hockey program. During the design review, Penn State entered the building 18 months prior to construction. And this was all done, again, via a 3D immersive cave environment. It's housed in the research lab on Penn State's campus. The cave experience is created by multiple projectors directed at 4 walls of a 10-foot by 10-foot room. Our team was able to walk down the steps and hallways, look into the community rink from the main concourse, read the displays in the arena, and enter one of Pegula's 14 suites without ever swinging a hammer. The owner was allowed to focus on specific areas with the coaches, athletes, and anyone else involved in the project. Spaces range from locker rooms to offices and suites to the actual rink itself. This ensured that scope and layout of these spaces met or exceeded expectations well in advance of construction. So on the slide, the first column is a description of what was realized. The second column, the cost of the change to the project directly as a result of the review. And the third column is the averted cost that we felt was realized as a direct result of the review. In the end, as you see at the bottom, we feel that, and we're confident to say, that VR saved this customer $475,000. Okay, so a few other real-world examples outside of Mortenson. In these, I'm going to show you how technology is being leveraged to produce visualizations that further enhance communication and understanding. All right, so we'll cue the first video here. This is from Iris VR with a tagline, "Inhabit your designs." Iris VR is a startup company that has realized the value and potential of VR applications for the AEC industry. At the same time, they recognize that true need is not as much to produce gaming environments, but to enable their users to do it easily and quickly. If we are making the use of this technology in a design review, our process can't be change and wait, change and wait. It's got to be change and assess. By allowing us to speed up this process, by letting the computer do the back-end work of porting a design model to a gaming engine, making unexpected changes becomes a lot less time-consuming and can be accommodated during a design review. Iris VR currently has a beta product that is compatible with SketchUp and are working towards a final product that allows Revit models to be integrated directly with their software. In the next example, which is from a company called UE4Arc, they're a company that sees the potential in VR technology in the AEC industry. And the example that's on screen right now it's an example of where I hope we're probably going to be a few years from now on the common project. What UE4Arc is doing as a company is striving to deliver architectural experience to projects while doing it in real time. They're producing some extremely compelling interactive content developed specifically for the Oculus Rift. So in the example, you can see the user navigating around the space. Pre-programmed modifications with interactive menus and information assist the user in manipulating the environment to their liking. By providing projects with interactive content, the users are much more easily engaged in the process. As you can imagine, the results of a design review has far more potential than reviewing 2D elevations and material samples, as a review has the capability to encompass the entire context of the project. So in the final example here, it's from a company called Arc Virtual. Pretty interesting company, composed of an architect, a group of really talented game creators, and CG artists. They're creating fully customized virtual reality simulations for architectural projects. In addition, they have a bit of a broader scope, where they approach scientific visualizations, doing sales and marketing, trade shows, and product demos and training. They're also doing medical event simulation. So while the video is impressive, when you start to really think about visualizations cross-pollinating in this manner to other industries, like you're seeing right now on screen, there are huge benefits. Not only can interactivity be provided, but easily digested information can be overlaid in the review. The potential for this approach to gaming and VR solutions has the potential to go far and beyond the design review. Training project staff on their new facility or operations and maintenance startup, I think, might look totally different in the near future as we start to engage these technologies. So the question is, will these technologies immerse us into a digital world or augment and enhance our physical world as we currently know it? I think it's probably going to be a combination of both. Technologies and devices such as photogrammetry for rapid content creation will make generating accurate content for these visualization techniques much easier in the future than it is today. Improvements in CPU and GPU speeds will lend to real-time physically based renderings. Also, VR device improvements such as the Oculus Rift Crystal Cove will lead to monumental improvements and ease in a more immersive design review. The third item here, a little bit about our social network society that we have going right now with Facebook and Twitter. I think it has the potential to lead to vast improvements in the architectural design review through solutions like mass gaming, or potentially even newer social technologies like crowdsourcing to get feedback, just because we can get a wider range of feedback in those types of scenarios. In addition, physics simulations, I think, will likely play a large part in future virtual mock-ups. In the end, I think the AC industry will continue to borrow from high-performance gaming solutions. However, real-time solutions, I think, right now still need development. So 2 last quick videos. Autodesk published a video almost 3 years ago now, highlighting some of these future technologies, and is still spot on with what really excites us as a company today. Reason being, it closely addresses a connection of the virtual and physical. It's quite obvious that this is a world that we'll be living in the very near future if we aren't already. We will continue to blur these lines of the existent and the non-existent to improve not only what we build, but also how we build it. New hardware and software technologies are just around the corner that will make enhanced visualizations something that is ubiquitous with our being. All of this will enable us as an industry to not only pre-visualize, but also deliver a better product. And our last and final video is from a company called DAQRI. They created what they're titling right now the Smart Helmet. So the DAQRI Smart Helmet is a fully immersive, or is a fairly new concept for a construction hard hat. It was unveiled by DAQRI in early September. They're a leading AR developer that has recognized a huge need for such a device and have a very disruptive concept off the ground. The core of the concept revolves around real-time information overlaid on the physical contextual environment. While it's providing information, it's also gathering it, all the way from pictures to video to 3D geometry. When you start to think about the enhanced visualization potential with technology like this, it gets really, really exciting. It's all very impressive, but the most important thing I think about this device is that it's designed to coexist along our industry workflows. Will the use of gaming and VR be game-changing for the AEC industry? That's to be determined. But I can say for a fact that if we don't fully assess the issues that we have and improve these new technologies strategically, that the game will not change for the better of the industry. We need to look deeply at the current and past methods of architectural representation, the current context, and only adopt these strategies when they provide real-world value while improving the experience of the viewer and improving the facilities that we are constructing. Thank you.